Hello, and welcome to my YouTube channel called Statistics from A to Z, Confusing Concepts Clarified. These videos are based on content from my book of the same name, which is published by Wiley. For more information on the book and these videos, please visit statisticsfromatoz.com. This video is one in a playlist on probability distributions. The playlist is planned to include a three-part series on distribution as a whole, plus individual videos on 9 different types of distributions, as well as several on the properties of distributions. See statisticsfromatoz.com/videos for the latest status of this work. You may find it helpful to view the first 2 videos before viewing this one, but that is not required. As usual in the book and in these videos, we'll go quickly through a list of keys to understanding, or KTUs, to give you the overall picture on one page, and then we'll go into detailed explanation of each of the keys. For this video, there are 5 KTUs. The first key to understanding tells us that normal distributions are continuous, and they are bell-shaped, left-right symmetrical, and they have tails which get progressively closer to the horizontal axis, and they have one mode, and the mean equals the mode equals the median. The second KTU says it takes 2 parameters to specify an individual normal distribution, the mean, mu, and the standard deviation, sigma. The standard normal distribution, whose test statistic is z, has mu equals 0 and sigma equals 1. Key to understanding number 3 is the empirical rule. It states that cumulative probabilities bounded by standard deviations are the same for all normal distributions, roughly 68%, 95%, and 99.7% for 1, 2, and 3 standard deviations, respectively. The fourth key is the central limit theorem. It states that no matter the shape of the distribution of the underlying data, if we take multiple samples, each of the same size n, and compute the means or proportions for each sample, the resulting distribution of sample means or proportions will be approximately normal. The fifth and final KTU says normality is an assumption for a number of statistical tests. And here on one page are all 5 keys to understanding the concept of normal distribution. You may wish to pause the video at this point to read them all together. Key to understanding number 1 starts off by saying that normal distributions are continuous. Continuous as opposed to discrete distributions like the binomial distribution pictured at left. The horizontal axis, the x-axis, of the normal distribution displays real numbers, so that there are an infinite number of possible values between any 2 integers. This results in a continuous smooth curve of the probabilities of the x values. KTU number 1 goes on to say that, as shown here, normal distributions are bell-shaped and left-right symmetrical, and they have left and right tails which get progressively closer to the horizontal axis. They have one mode, and the mean equals the mode equals the median. Key to understanding 2 starts out by saying that it takes 2 parameters to specify an individual normal distribution, the mean, mu, and the standard deviation, sigma. The mean tells us where on the horizontal axis the center is located, and the standard deviation tells us whether the distribution will be tall and narrow or short and spread out. There is one special member of the normal family of distributions. KTU goes on to say the standard normal distribution is the normal distribution that has a mean of 0 and a standard deviation of 1. As shown here, The vertical axis is for point probabilities of the points on the horizontal axis. For example, we can see that the point probability of 0 is about 0.4. The horizontal axis shows the values for the test statistic z. These values are in units of standard deviations. The standard normal distribution is also known as the z-distribution. Test statistics like z, t, f, and chi-square are used in hypothesis tests and in tests involving confidence intervals. Z is used in tests of proportions and means. There are or will be videos on the book's channel on all these individual subjects. Cumulative probabilities are calculated as areas under the curve of the distribution. Key to understanding number 3 is also known as the empirical rule. The empirical rule states that cumulative probabilities bounded by standard deviations are the same for all normal distributions. These are roughly 68%, 95%, and 99.7% for 1, 2, and 3 standard deviations, respectively. That is, the cumulative probability of all points on the horizontal axis between -1 and 1 standard deviations is around 68%. The cumulative probability of all points within 2 standard deviations of 0 is around 95%, and that for 3 standard deviations is around 99.7%. These percentages apply to all normal distributions, whether they are tall and narrow or short and wide, like those shown in an earlier slide. The previous slide showed that we know all the probabilities for the standard normal distribution. The empirical rule is very useful because it enables us to use these known probabilities from the standard normal distribution to calculate point probabilities and cumulative probabilities for any normal distribution. Here we show an example in which the tester has selected a value of 5% for alpha, the significance level of the test. For a right-tailed test, we graph this as a shaded area under the right tail. The z-distribution can tell us the value for the left boundary of this area. It happens to be 1.645. This boundary is called critical value. It is in units of z, that is in units of standard deviations. In any other normal distribution, it will also be 1.645 standard deviations from the mean, but we need to convert z's unit of standard deviations into units of the data of the other normal distribution. We do this by using the simple transformation formula, x equals 1.645 times sigma plus mu, where sigma is the standard deviation and mu is the mean. The central limit theorem, CLT, is a powerful concept which helps us perform statistical analyses on any population or process, no matter the underlying shape of its data. We just take samples of data with replacement and calculate the means for those samples. The resulting distribution of these means of samples will approximate a normal distribution, and then we can use known facts about normal distributions, like their cumulative probabilities, in statistical analyses. There is something intuitive about the CLT. The means of a sample taken from any distribution is very unlikely to be at the far left or far right of the range of the distribution. Means by their very nature tend to average out extremes, so their probability would be highest in the center and lowest at the extremes. Note that x, representing the data, is the horizontal axis for the two strange distributions left of the big arrow in the top diagram. However, for the distribution of the sample means, the horizontal axis variable is x bar, the sample average. The points on the horizontal axis represent values of means of samples taken, such as a distribution of a statistics of a sample is called a sampling distribution. N is the number of individual data points in each sample. It is not the number of samples taken. As n grows larger, the distribution of the means of the samples approaches a normal distribution more closely. For n greater than or equal to 30, the approximation will be very close. Some say that there is no reason to go any higher for the sample size. In fact, for use with control charts, a sample size as low as 5 can be used. The central limit theorem applies to proportions as well as means. A number of statistical tests, for example, t-test, z-test, and ANOVA, require that the data is roughly normal. Different tests have different levels of sensitivity to how non-normal the data can be. The Anderson-Darling test is often used to determine normality. Okay, that concludes our clarification of the concept of normal distribution. If you liked this video, please remember to press the thumbs up like button on your screen below. I'll be making more videos of some or most of the 60+ concepts in the book if folks like you tell me that more videos are wanted. Please subscribe to this channel to be notified when new videos are uploaded. Also, the website statisticsfromaz.com has a listing of available and planned videos. Now, videos like this one can be very helpful, but they're not very handy when you want to quickly look up something on the job while studying or during an open book exam. For that, nothing beats a book or an ebook. You can also learn more about those on the website. I'd recommend following my blog at statisticsfromaz.com/blog. I've got some things there that hopefully you will find interesting, like a statistics tip of the week series, as well as posts showing that you are not alone if you're confused by statistics. I'll also be posting on the Facebook page, Statistics from A to Z, and on Twitter as @StatsA to Z.